Okay, this is continuing on in section 3.9. Again, we're talking about hardware description languages. And just to emphasize this, companies that design and integrate circuits use proprietary and public HDLs. In the public domain, the IEEE supports the following standardized HDLs: VHDL, Verilog, and System Verilog. VHDL is a U.S. Department of Defense mandated language. The path of development of Verilog ultimately led to its being a proprietary HDL of Cadence Design Systems, which transferred control of Verilog to a consortium of companies and universities known as Open Verilog International. As a step leading to its adoption as an IEEE standard, system Verilog evolved mainly from Verilog and from Superlog, a proprietary language held by Synopsys Incorporated. The Verilog 2005 language is embedded within System Verilog, so our text will consider Verilog before presenting a brief introduction to System Verilog. Our design. We have these are keywords, by the way, module, in module, input, output, wire, or not. Our design is that we have a module, and within that you have some lines, and then you have an in module. So we have here we have a module, some kind of name, and then an in module, and then we have lines inside here. Specifically, what we're working with is a Verilog model. So this is different than a standard programming language, but it's more. I think of it more as a design standpoint. And we looked at this with the or and the and so forth, and then a wire in between. And I have no clue what they have here. I mean, this is right up here. D is equal to A or B. D is equal to A or B. E, which is right here, is equal to C and D. So C, and here's the and, D. So that all makes perfect sense. Then it's a logic diagram schematic for the Boolean equation D equals A or B and E equals C and D. I think that's a typo. Doesn't make any sense with what they have. It should be E equals, and then we got C coming in. Actually, these are that's an or, so A plus B, and then the C's coming in here, so C A plus B. So E is equal to C and A or B. which then is equal to C and D. So, okay, that makes sense with that substitution. Okay, we talked about the assign. The assign, remember, is where this is where your Boolean algebra portion occurs. This up here is where you declare what your input's going to be and what your output's going to be. And then if you have a value that you need to have in between, you refer to as a wire. Just like what we said. This right here, this D here would be a wire. As we look at this one, this D right here would be a wire because it's an intermediate variable. It's not one of the inputs, it's not the output, so it's a wire. And this is one we looked at last time, or we programmed that in. Okay, I'm just going to work examples. So let's do this one right here. We'll do, I guess they want us to do it in one model. Okay, so we'll have E and F as our outputs. We'll have A, B, C, and D as our inputs, it appears. Okay, so we'll have A, B, C, and D for inputs. For outputs, they have E and F. And we don't need a wire necessarily. And I don't remember the comments. I think it's that. Book in C is equal to A plus BC plus D prime D. So we're going to assign E equals to A, and the plus again is an OR. So OR B and C. That's what the BC next to each other indicates. Then there's another plus, so that's an OR. And then not B. I'm not sure if I need to put parentheses around it, but I'll put it that way and we'll see. And then it looks like times D, so it's an and, so not B and D. Next one is F is equal to B prime C plus B C prime D prime. So we're going to assign F equals to not B and C. There's a plus between them, so that's an or. Or B and not C and not D. So we save that and compile it. Okay, testing is successful. Okay. Okay. Now I put parentheses around this portion right here. I don't know if I need it or not. I don't know what the order of operation says in terms of does it do the and or first. So to make sure, I went ahead and put parentheses around this just to ensure that it's going to do that and first, and then do the or. So something to keep in mind. Okay, so now I'm gonna go over my library tab, expand work, and hopefully I see some files. I do. I still have one extra left over. I don't know how to clean that. Delete. If I don't mess this up. Really delete design unit. Okay. So with this, I'll right click on it and I'll do a simulate. Go to my wave tab. And I'll drop on A, maybe. There it goes. Drop on A, drop on B, drop on C, drop on D, and drop on my outputs, E and F. Okay, and I'm gonna force this. So I'm gonna right click on it and choose force. And I'm gonna set it to 1. This one I'm gonna right click on, choose force, set equal to 1. Looks like they're all set equal to 1 to begin with, but I'm gonna go ahead and show it. Okay. Run my simulation. Remember that's right up here to the right of this 100 nanoseconds. And it looks like this one's 1 and this one's 0. You can see the values we have right here. So 1 and 0. Well, let's see if that's right. Think this through. Again, the multiplication are the ones that look like multiplication we treat as multiplication. So I got 1 and 1, that's 1. And this is a 1. We got, not B, which is 0, and 1. 0 times 1 is 0. So we got 1 plus 1 plus 0. And that gives us 1. So that checks. If I were to plug in not B, that's 0. 0 and C, which is 1. 0 times 1 is 0. Down here, fact that these are knots means this gives me 0. So 0 or 0. Again, you treat it like addition, except for the weird one, 1 plus 1. So 0 plus 0 is 0, which is what I came up with for my output here. This is something, if you're simplifying a Boolean expression, you wonder, did I do it right? This could check it. If you put in your unsimplified version and your simplified version, and they give you the same outputs when you plug it, change all of your inputs, then that verifies it. Okay. Here's their solution. They put the parentheses around the knots. Other than that, it's probably still the same. Yeah, let's see. Let's see. See, this description illustrates that the declaration of the modes of the ports may follow the port list rather than be included in it. It's exciting there. Design encapsulation in VHDL has two parts: an entity and an architect. A VHDL entity provides a name by which the design can be identified and specifies the interface of the design with its environment. Name and direction, i.e. mode of each interface signal and its data type are declared in the port of the entity. Syntax template of entity is given below. Here they got an example. In this, the functional description of a design is provided by an architecture. So we have our name of our entity is declarations, data types, declaration signals, definitions of functions, procedures, and then declaration of components. VHDL is not a case-sensitive language. Language keywords are shown bold, and so forth. And here it looks like a VHDL example. I never have done a VHDL in this, so all I ever did last year was Verilog. So I'm gonna do a file, new source, and choose VHDL. We'll talk about what each one of these means, assuming I can type it in and compile it and so forth. Big assumption, assuming I can actually see it. Okay, that's a dot all. Entity or and VHDL is port A, B, N, standard logic. E is out, standard logic. And or and the VHDL. Boolean equations of or and VHDL is signal D standard logic. Again, D is less than or equal to A or B. E is less than or equal to C and D in Boolean equations. Okay, we'll come back to examine the code if it compiles and so forth. So just save that. Okay, come over to my project. Maybe. Maybe it didn't actually add it to the project. Let's see. We'll right click over here and add to project. Let's see if I can find an existing file. Browse. And then click OK. There it is. When I did a new on that, I didn't create a brand new one. I had to come over here, right click on it and choose add to project, existing file, and then go double click the untitled VHD. Okay, let's see. I got that saved, I think. Yep. Okay, so right click on it, choose compile. Oh, okay. Okay, I think I see a mistake. Lord, that can't be right. Okay, change that to uppercase D. Of course, it didn't give me an error. If you've already saved it, to add it to your project, you right click on the file, right click on a white space here, and you say add a project, existing file. To the right should be a browse. And you click the browse. Then you should be able to pick your file. Okay. Then after you get it added, go ahead and compile it. Make sure you don't get any errors. Now we're still running our simulation, so I'm going to stop it. I'll do simulate in simulation. It says, do you want to quit simulating? Yes. Just to be on the safe side, so it's good bouncing around. I'm going to go to project, and I'm going to right click on untitled 1.vhd and do a compile again. So compile selected. Okay, tells me it was successful. If I go to my library, um, here is our entity, and then under entity we have our architecture, which refers to the Boolean equation. So I'm going to right click on the entity and I'll choose simulate. Okay. Go ahead and share your screen. Library IEEE, use IEEE dot standard underscore logic dot 1164. You need a dot all on line 2 and a semicolon. Uh-huh. Okay, so I got my, in your case, go ahead and right click on it and choose simulate. Now go to my wave tab right there. I'm gonna drop on A, B, C. Those are our inputs. And E and D. We try to force these. I'll right click on them, choose force. Value U. What does that mean? Put one there. Right click on this one, choose force. Choose one for the value. Then right click on this one, choose force. Put one for the value. Now run my simulation by clicking this button up here. And A or B. Both of them are 1. So 1 or 1. Again, we treat the or like addition. Therefore, 1 plus 1 does not give us 2, it gives us 1. So I can buy that this 1. My other one is C and D. Okay, here's D down here. C and D, I treat that like multiplication. Okay, so if D is 1 from above, and then C is 1 and 1's 1, so it gives me that. Okay, that all checks. Questions on that? Let's take a look at the code then. Okay. Previous page, talking about the differencing entities and architectures. Let's say anything about the IEEE. But I'm assuming you have to have that library here in order to do this. And that's probably just standard. Okay, so here we got our entity defined, and that's right here. This whole shooting match is our entity. Give it a name, or and VHDL is, and then there's an and, or and VHDL here. And we have A, B, and C as input, standard logic, and then E is output, standard logic. It's first calculating A or B, and then taking the value of D and plugging it in here and doing C and D. And then end our Boolean expression, which is our architecture there. So let's see. Let me implement this. Go back to that first example we did today. Grab a drink here. Okay, I'm gonna stop my simulation. So do simulate in simulation. Okay, entity or and VH. Okay, I need my inputs. We got A, B, C, and D inputs. Then we got E and F for our outputs. This is kind of all standard, unless it's the or and VHDL. I don't know about Boolean equations. I think that's user defined also. Maybe because the color plus the purple is what you define. We could have a D, and we may need it. I don't know. But let's go E is equal to A or B and C, or not B. I wonder if that's not B and D. And F is going to be not B and C, or B, C, and not D. Save that. Go to my project. Right click on that and choose compile. Compile selected. Didn't like that. Let's see. Prior declaration of deed. Let me just get rid of this. I don't know if that'll work. Save that. Choose compile. Compile selected. Line 8. Save that. Right click on it. Choose compile. Compile selected. One error. Expecting is. Well, that's not very good. That'll probably work, but I wonder how you tell it you don't have any. Assuming it allows that. Okay, successful. Put a dummy in. Yours does? Okay, I'll give it to. Go ahead and share your screen. The what? The last red line. Find flow. I have uppercase on my letters. I wouldn't think that'd matter. Didn't? Okay. Right. Did it work? Okay. Could be you just didn't even save it. It's a picky package. It really is. I'm used to like Visual Studio popping up like when I start typing something, it pops up with the code completion and so forth, and guides me with little red squigglies when I got something screwed up. Um, this is like the programming of 20 years, 30 years ago, where you have to double click the error messages you get, which line number. And okay, see, I'm gonna compile it again just to make sure I got it compiled. Come over to my library, to my entity here. I'll right click on it and choose simulate. I'll go to my wave tab. And I'm gonna drop A in there, I'll drop B, drop C, drop D. Also E and F. Don't need drop G because that's just that bogus one I put in there. Now force these all to be ones. So right click on that. If I can do all in a range. Doesn't look like it says VHDLA. Oh, sure enough, it'll pop up. One, one, and one. Now I'll start my simulation. Yeah, if my memory serves me right, we got 1 and 0 before. So that would be correct. Did yours work okay? Um, oh, that wasn't it here. Okay, so it says write a signal. Oh, I don't want to cheat and look at the answer. Write a signal assignment statement that implements the logic diagram in here. And in VHDL. Okay, so F is going to be our output. We're going to have three inputs, A, B, and C. D that's used in the middle. So D is equal to what? Not A or B. Yeah. Is equal to not D and C. Okay, so I'm going to stop simulation. I'll do a simulate. Ah, there it goes. In simulation. They might have the best package ever if you actually buy it. Maybe the free version's a pretty scaled down one. So I shouldn't even say that's not a very good package. Okay. What do you say? You're gonna have A, B, and C as inputs, so that's fine. Get rid of the D, and our output will be I think that says F. And then architecture, essentially we use one signal. I'm assuming if you want to use more than one, you have to separate them with commas, which is D. Um, I don't know. I don't think so. Oh, okay. Okay, so going backwards. Um, that says F equal to not B and C. And right here, D is not A or B. Okay, so I'll say that, and then go to my project window, and right click on the VHD, do a compile, compiled, okay. D is my intermediate signal. One change. Okay, compile again, make sure I got it compiled. So it's compiled. Over my library. Right click on that to simulate. Go to wave tab, drop A, B, and C. I need C. That wouldn't hurt to actually check it. I'll put D in there temporarily, and F. Okay, I'm going to force these. There's got to be a way to do a parameter on this. This is model sim parameters on simulation. Model sim simulation force parameters. Uh-huh. Yeah, that's what mine did the last time, but there should be some way to put a parameter in there. We don't even have to do that. Dollar maybe. Okay. If I do a force here, for the value, I'll put $1. Well, I won't worry about it. I don't know what U stands for. I assume it's not really. That could be. Those three forced. Then I'm going to run my simulation. Gives me 1 and 0. D is 1. Not A would be 0. B would be 1. 0 or 1 plus 0 plus 1 is 1. Okay, so that's 1. So this says not D, so it'll be 0 and 1. You treat the and like multiplication. 0 times 1 is 0. And that explains why F is 0. Okay, so it appears to be working. You can't say for sure unless you run through all the possibilities. 111, 110, 101, 100, 0, so forth. Okay, I'll stop simulation on that. Not what they had as the answer. I still don't agree with that concept. They put D in the logic diagram. Seems like to me D should be in the program. Oh well. Okay, example 3.1, constructed Verilog and VHDL models based on Boolean equations applied by the logic diagram of a circuit. Another approach is to use language constructs directly to form a structured model of a circuit. Structural models describe how a circuit is composed of other interconnected items such as logic gates or functional blocks. Verilog has a number of built-in structural objects. The Verilog primitives are AND, NAND, OR, NOR, XOR, XNOR, buff for buffer, not, buffer if 0, buffer if 1, notify if 0, and notify if 1. They were described briefly here. Most Verilog input primitives that automatically accommodate 2 or more inputs. Thus, the same keyword denotes a 2 input or a 5 input gate. Okay, I think they indicate that's our wire in the previous one. I understand the principle behind this. I don't really understand it though. But the idea is you have these coming in different speeds. So this, for whatever reason, through this gateway, takes 30 nanoseconds. While doing an invert is a faster operation, it only takes 10 nanoseconds. So this is coming in, this reaches there first, and then this comes in afterwards. And this talks about putting a delay in there. Down here we have our time scale. 1 nanoseconds, 1 PS. I have no clue what that stands for. But this, my eyes aren't failing me. I think that's comment. Then we got our module, in module, got to give it a name. We're bringing in 3 inputs, A, B. We got 2 outputs, D and E. We got 1 wire, which is W1. And then some code. The and just through me having the and, not, and or in there. It's just this is Verilog. But this almost looks like VHDL. Anyway, we've got G1, which is dealing with A and B. Hang for a second. This one's not so easy to see them. You have to actually read. Okay, structured model of the circuit in figure 3.37. And or prop the list of predefined primitive gates, each identified by a descriptive keyword, i.e. and, not, or. Circuit has 1 internal connection between gates G1 and G3. That's what we're talking about here. Between G1 and G3 is the W1. Gates are connected by W1, which is declared with the keyword wire. Elements of the list are referred to as instantiations of a gate, each of which is referred to as a gate instance or primitive instance. Each gate instance consists of a primitive name and optional instance name, such as G1, G2, and so on, followed by a list of comma separated gate output and input enclosed within parentheses. Rural language is that the output of a primitive gate must be listed first, followed by the inputs. Okay, I think I see it all. Bring in his inputs, output in D and E. It's right here. Wire is W1. So W1. Then there's an AND, G1. That's a name we're giving it. And this talks about the prop delay. Then we got the AND right here specifies it. So the AND is this right? That's right. That right there. And then A and B. That's from this right here. A and B gives us that. Gives us our W1. The not G2 has 10 nanoseconds. It's got a not. So it's not a buffer, it's an inverter. Let's give us E, and we're taking C in. E is equal not C, correct. This is giving us D. Oh, and it's bringing in E. Okay, I see it. Because E branches off up here. Let's put that in there and see. Okay. This is back to my Verilog. So module input E. Output D and E. Wire W1. E1. Outside 30. W1. AB. Not G2. Outside 10 to the delay. EC. Or G3. Outside 20. D, W1, and E. Save that. And right click on testing.v and then compile selected. 2 errors. Line 2. Output EE. That would do it. Three errors. Making it worse. One error. Line 2. Well, I'm wondering. That's the only difference besides the order of input and output. So now I think it should be the same. Still not. Says then like in line 2. Module, got a different name, but same idea. Beginning parentheses, input, A, B, and C, semicolon, E and E, close parentheses. Wire is W1. Module. Unexpected semicolon. Expected. Okay. I don't understand this, but they got an extra one here. Line is necessary. Probably is. I'm looking at it. It's not a comment. Time scale 1 nanosecond to 1. Yes. Is yours working? Oh, it isn't? Okay. Time scale 1 NS 1 PS. Module. Shouldn't matter about the name. Beginning parentheses. Like that was a comma before. Let me go back to my previous. Yeah, it is a comma. I had output first. Not that I don't think it matters, but output. Oh, you don't have an error? Uh, Module XOR output, and then that. No, have this on a separate line. Not that that matters. Wire W1. I'm going to save this. We go to my project. Right click in here and choose add a project new file. And choose System Verilog. Save it. File. I'll select it. Well, that's not System Verilog. That's we got an unexpected base, huh? Looks like a single quote, time scale, one. It's got that, but that's time units per resolution. There it is. It's the other single quote. Boy, I could have spent a long time on that. I did spend a long time on that. The the one it's looking for is the one in the upper, far upper left corner. Do you see the single quote? Okay. I'm almost sure that they don't have that right quote on there. Which is maybe not surprising because they got another error in their code. Uh huh. Oh, I have to close mine. Okay. I figured to pop up and ask. Oh, okay. Yeah, go ahead and close that. Okay. Module FE wire W1 and G1. Module. Let's see what mine is. I did mine under the not under the SV, but under the V. So copy that, go to testing.v to tab, and put it there. Three errors. What pound did you use? Did you use shift? Where in the world is pound? Shift 3? Hmm. Yes, I do. An input, A, B, C. No, you had it right. I had my beginning parentheses and semicolon before my wire. I don't know, input and output there. No, mine's output. Never mind. FE input ABC. where W1 or wire W1 semicolon and G1 pound sign 30 beginning parentheses W1 AB not G2 pound 10. Go ahead and save that. Just make sure it was saved when we compiled it. I'm gonna request remote control. So go ahead and allow it. Okay. And don't mouse while I'm doing this, otherwise it does weird things. Shouldn't matter. When you get down to the point where it looks exactly the same except for that one thing, then yes. Yeah, that's a weird part of it. Not G2, not G3. Pound 30, pound 10, pound 20. Okay, that's working. Wire W1. That's working. And G1, pound 30, W1, A, B, semicolon. That's not working. I'll see in a second. Only thing I see line there. We'll get rid of that W. There. I was thinking maybe you had a one there and an L somewhere else, but now they're both W. Yeah, it's not looking good. So it works perfect down to here. No errors at all. And when I put this line, unexpected integer number. Shouldn't be, because I installed mine about the same time you did. Um, let's see. 10.48. Yeah. And G1, pound 30. What in the world's pound mean? Verilog primitive is a built-in logic to determine the behavior. The optional user-specified propagation delays to determine the time interval between a change in the input signal of the gate and the effect apparent at the output of the gate. That is, the model reflects the fact that the gate is not instantaneous. It is important to understand the distinction between declaration and instantiation. Um, well, 16, just does not like pound. Yeah, I was playing. Next page talks about how you can pass in binary on page 132. And they do one and then that weird single quote, then B for binary. Um, so I was thinking maybe that was the key to it. That didn't work. Um, let's see. The NS, the nanoseconds. What in the world's a PS? Hmm, time scale. PS. Module. Input. ABC. Wire. And G1. Pound sign 30. I don't think I'm gonna figure that out. I think I could spend a year on it and still not figure it out. We won't worry about that example. If they had it right in the book, I might be able to tell. But see, I'm not even sure if we're doing it right from the book. That's the issue. See, the program's drawn in the book here. There's two issues. You see how they have a semicolon right here? Well, that should be a comma. And see, they have a beginning parentheses here, and they have a closing parentheses and semicolon here, but then they got an extra one. Without knowing what it actually should be, yeah. Let me finish mine and see what it looks like. Okay. Oh, mine isn't working. What did I get to work? I must have been on the wrong one. I was on VHDL. Propagation delay. Delays specify a time which the sign values propagate through nets or from inputs to outputs. Why? Oh. Well, we won't worry about that. Like I say, if the code was right in a book, we could actually check it. But you can't have a closing parentheses without a beginning parentheses, no matter what in these. It's right there. It's flawed. And I'm pretty sure there should be a comma, but they have a semicolon. So who knows what else they have wrong? Um, no. Let's put a semicolon here. Let me type it in exactly as they show it. kick in the head if it actually works. They have output D and E. D and E. Oh, that can't be it. I had F. How many times did I look at that? So now I gotta get this. Oh, what? Oh, G1, yeah. Three errors. Thought I did, but let me try it again. Get over here. Yeah, I did save it. You still got errors? Okay, but they have a semicolon here. One error. I'm down to one error. Unexpected, expecting close parentheses. A, B, C, D, E, wire W1. In fact, to three errors. A, B, C, D, E, W1, W1, A, B, E, C, D, W1, E, G1, G2, G3, and not or # 30, 10, 20 in module. Well, it's definitely an error what we had. Comma DE. Out with DE. Comma. Hmm. Well, we won't worry about that one example. Like I say, I know the book has an issue. With that close